Hi, in this video I'm going to show you how Venn diagrams work. So here I took a survey of pet ownership and I asked people if they owned a dog or a cat, both or neither. And I put the results here in this Venn diagram. We can use this Venn diagram to figure out how many own a dog. And how we figure that out is we want to look at the circle with dogs. Everybody inside this circle owns a dog. So that's these 8 people plus these 6 people here, which is 14. How many people own a cat? Just like with the dogs, all of these people inside here own a cat. That's 6 plus 5, 11 people. Some people own both a dog and a cat. So how do we figure out how many people own both? Well, that's going to be the people in the middle here because they're inside the circle for the dogs and inside the circle for the cat. These people here own both. So that's going to be, and you see when we did our addition, that 6 is represented here. So how many people own neither? These are the people that are not inside either circle. And that's what this 13 here means. So that's 13. Let's figure out how many people don't have a cat. That's going to be everybody outside of the cat circle. Everyone who's not in the cat circle. So all of these folks don't own a cat. That's going to be this 8 here plus this 13 here. So 21 people. All right, so then what is the total number of people represented? What we could do is we could look at how many are the dog owners and how many are the cat owners and how many own neither. The problem with that is we have to be careful because remember over here, we've got these 6 people that are in both circles. So with the Venn diagram, the easiest way to figure out how many people total are represented is to just add all the numbers we see here. How many people have neither? How many people only own a dog, own both a dog and a cat, and own only a cat. So that total then is going to be 13 plus 8 plus 6 plus 5, 32 people. We can also represent this information in what's called a two-way table. And it's called a two-way table because we can read it 2 ways. We can read it down, have a dog or don't have a dog, or we can read it across, well, have a cat or don't have a cat. Usually we prefer the visual Venn diagram if possible, but sometimes we only have a table. So let's take the information from this Venn diagram and put it in this table. So how many people, this little box here is how many people have a cat and have a dog. That's going to be these middle people here, 6 people who have both. How many people have a dog but don't have a cat? That's these people here. You see they do have a dog, so they're in the dog circle, but they don't have a cat. So that's just this 8. Okay, so the total people who have a dog is 6 plus 8 or 14. And you see that same 14 is here. And how many people have no dog but do have a cat? Well, that's going to be these 5 people here because we know they have a cat, so they're in the blue circle, but they don't have a dog, so we don't count this 6 people. So we only have those 5 people. How many people have no dog and no cat? That's these 13 people that are not in either circle. Okay, so total, how many people have no dog? We're just going to add these 2 up and we get 18. Okay, and then we can find these totals over here on the right by adding across. So how many total people have a cat? 11. And you see this is that same 11 we got up here in number 2. Okay, how many people have no cat? Add 8 and 13 to get 21. And you see that's the same 21 we saw here. Okay, so how many people are represented total? You can double check your work by adding these 2 numbers and these 2 numbers because they should get the same thing. And we see the total is 32, which is also what we found right there. Okay, let's do some examples of how we use this. A lot of the point for Venn diagrams in this two-way tables is to figure out the probability. If we randomly chose one of these 32 people, what's the probability they satisfy a certain criteria? The probability of an event occurring is written in this shorthand P of A. So to find the probability, we use this formula here. The number of items satisfying the given criteria, which is in this case, I'm just using A as a placeholder, divided by the total number of items. Okay, and I think this will make more sense if we look at an example. Find the probabilities given writing a fraction, a decimal, and finally a percentage. If we look at the first example, this says the probability that a random person has a dog. To calculate that, what we're going to do, find the number of people having a dog divided by the total number of people represented, 32. Of all these 32 people represented in this Venn diagram, how many own a dog? Remember, dog owners are everybody in this circle here. So the number of people owning owning a dog is 14. We found that above as well. We want to figure out the decimal, and remember this means 14 divided by 32, which is 0.438. And we're going to write to 3 decimal places. And that's pretty much a convention that we're going to use throughout this entire class. Okay, so the probability of having a dog is 0.438 or 43.8%. Okay, so next let's find the probability that somebody owns a cat. Remember, all the cat owners are inside this circle here. So we see we have a total of 11 cat owners out of those 32. As a decimal, that is 0.34375, but we only want 3 decimal places. So we want to get rid of those, which means we need to round this one up. So what we're going to get is 0.344. 34.4%. And remember, to find the percentage, what we're doing is we're multiplying by 100. So let's find the probability that someone owns both a dog and a cat. People who own both a dog and a cat are in both the cat circle and the dog circle. That's this area here, 6 people of the 32. So that's 0.188 or 18.8%. Now in statistics, we're mainly going to use this 0.188 as our answers. Find the probability of neither. The neither folks are not in any circle. So that's these 13 people here. So 13 out of the 32. So that's 0.406 or 40.6%. What about the probability that they own a dog or a cat? So this is a little bit different before, where we had the and, but we were looking at the overlap because they had to be in both circles. When we're looking at the or, we need to include both the cat owners and the dog owners. So what we're looking for is everybody that's in either the dog circle or the cat circle. Here, it's nice because we have the Venn diagram. This actually makes it a little bit easier than if we were going off of a table. The people who are in either of these circles, we have these 8 people, plus the 6 people who own both, plus the 5 people who only own a cat. So it's only a dog, plus the people who own both a dog and a cat, plus the people who only own a cat, out of the 32 total. So that's 19 out of 32. So this is 0.594 or 59.4%. Let's find the probability of not owning a dog. In this blue circle are all the people who own a dog. If we want to find the probability of the people who don't own a dog, what we're looking at is people who are outside of the dog circle. Okay, so what that means is we're looking at all of these folks here, everyone who's outside that dog circle. So do you see, it's everything but the dog people. So we have 13 plus 5 out of that 32, and we have 14 out of those 32 who are dog people, and 14 plus 18 is 32. So these two combine to cover everybody, because either you own a dog or you don't. 18 divided by 32 then is 0.563 or 56.3%. Turns out if we add this 48.3 with this 56.3, we get 100%. And that's because these are what are called complements. And that's something we'll talk about a little bit later. Hopefully that helps explain Venn diagrams. Thanks for watching.